cooperate. Okay. So now, what is the quadratic formula?
X equals negative b plus or minus square root of b squared minus 4ac over 2a.
Now, real quick, let me use this example to kind of introduce some new stuff at the same time. How could you, what part of this would make the answer come out complex? How would I know ahead of time if it was going to be complex or not? Where do complex numbers come from?
If it was a negative result in the...
Yeah, if this was negative, then the answer would have complex numbers, right? Does that make sense? I like it. Cool. So we, sometime in history, mathematicians, they said, holy shit, that's kind of important. Let's give that its own name. We call this the discriminant because it discriminates between real and not real, right? Call it the discriminant. So real quick, even before I do any real work, some problems in the homework just ask you to look at the discriminant and tell me if it's going to be real or not. So let me just look at b squared minus 4ac by itself for a second. What's b for my problem? Negative 7. A was 11 and C is 9. So I get 49 minus 44 times 9. Yeah. All right. 11 times 9 is 99. So 100 times 4 is 400. 99 would be 4 less 1. I screwed. And so that's going to come out negative, right?
Yeah.
Negative 347. Yeah. I like it. So what kind of answers will I get? Complex answers. Again, why do I know it's going to be complex? Because that number is what's going to be in here. I like it. So kind of doing that first is also kind of nice because now I can just put that number there. So some of the homework only wants you to do this. You actually don't even have to do this. But in general, it might not be bad just to do this on the side and now I can just throw that number in there. So now completing this, I get x equals, yeah, good, positive 7 plus or minus square root of negative 347 all over twice, yeah, 11, so 22, I like it. 7 plus or minus, what's the square root of negative 1? I. What's the square root of 347? I don't know, we have to look at it to see if we can do anything. I mean, the numbers are big and gross, but it doesn't matter. Yeah?
When would we use quadratic?
Well, here's one example of when I would use it, right? So here is the thing quadratic formula does. It solves quadratic equal to 0.
Quadratic.
Right? That's what it does. It solves this. That's its only function is to do this.
We also got and this does the same thing as completing the square?
Yes, in fact, it is completing the square
A different way.
done first. Instead of, I completed a square before I threw in specific numbers. Instead of completing a square with this specific number to begin with. So it is the same thing as completing a square. I just kind of did it first without any numbers. So I can throw the numbers into the answer.
Yeah.
So this is the answer. These are the answers. That's the answer. I just got to throw the numbers in the right place. The reason that I have work to do is because now I have to simplify this shit. And that's why sometimes quadratic is not quicker than completing a square itself. Because I still have work to do for the quadratic. Now, real quick. I mean, this is what it does. But what else does this do? I mean, if I had y equals ax squared plus bx plus c, and I made y 0, what is it that I'm looking for? If I make y 0, I'm looking for the whats. So when I make x 0, I find a... So when I say y equal to 0, I find the... So since quadratic formula solves this type of equation, it also can be seen as giving me the x-intercepts of a quadratic. So it's where the parabola is going to hit the x-axis. Those are the x-intercepts. So it doesn't actually do two things. It does this one thing. It's just that when does this happen? Well, sometimes it happens because I'm looking for the x-intercepts. So that's the quick way to find the x-intercepts for any quadratic function, is just to use the quadratic formulas. So one thing I use it for is intercepts. So what does this mean then graphically? Does this have any real x-intercepts? Does this have real x-intercepts? What kind of intercepts did we get?
Complex.
Complex. So does it have any real intercepts? No, it doesn't have any real. So what does that mean about this parabola? It means it looks like that maybe. It doesn't have real intercepts. So when I graph it on a real plane, I'm not going to see it hit the x-axis. I really want this to make sense. That's why I get these funky answers, because it's freaky. It's not real. So a parabola, since a parabola turns, there's a ton of parabolas that have no x-intercepts. And this is what it would mean. So if it has no x-intercepts, that means you would get complex answers. If you get complex answers here, it means it has no real x-intercepts.
Which means it has no y, or can have no y-intercepts as well.
Always has to have a y-intercept, always. Because you can always make x 0. I really want this to make sense. Is there any reason I couldn't make x 0 here? I can always make x 0, and then what's the y-intercept? See? There's always a y-intercept, always. Because it can't avoid the y-axis. It can't. I really want this. Can it avoid the x-axis? Sure, it just goes, I don't want to hit you. So it can avoid the x-axis because...
It never stops going out.
Yes, exactly. This is like related to what we were talking about the other day. So even if you're like, no, I'm going to start mine way over here, well, still, so eventually somewhere it's going to hit the y-axis. There's no way it can escape. It always has a y-intercept. Algebraically, it's because I can always make x 0. But I can't always make y 0 with real numbers. Oh shit, there's an example. Well, this is the look that math teachers get used to. Sorry. Does any of that make any sense? I mean, if geometrically it can have no x-intercepts, it's got to mean something weird when I try to solve it algebraically for the x-intercepts. And this is the weird thing. It comes out complex. That means this kind of answer for this means it would not hit the x-axis with real numbers. Right? That's what it means. That's the connection between those two things. Okay. All right. So what do you really need to take away from this? Are you able to use the quadratic formula? Yes. I don't care what numbers. I can give you decimals here. I don't care. Of course I don't care. You know, I'm an unfeeling math teacher. I don't care. But you just plug them in. If there's really rows, you got a calculator. Who cares? What I'm concerned about is, do you just know this formula and do you know how to use it correctly? That's what I'm checking for. It doesn't even matter how ugly these numbers get, because you just do whatever it says to do after you plug them in. That's all. Nothing major. Oh, yeah. Okay. So anything else from homework stuff, or?
There was one on line that said the minimum y value on the graph.
Oh, good. So that's one thing we still got to fill in, but that's a perfect lead-in. What can you tell me? Let me see which way to approach this. What kind of parabola would have a minimum? I love that question, because what kind of parabola would have a minimum and would have a lowest point? Yes, it'd have to be one that opens up. Right? And of course, a maximum has to happen when I have one that opens down. So this happens very often. My profit function looks something like this. And I'm like here, and like, well, Johnson, we want to get here because then we can make the most profit. Okay, we're going to move there. The hard part is, there's people who are called financial analysts. A friend of mine did that for a while with Dell, and he's making 6 figures. He's also got 5 kids, so it goes away. But every day, this parabola moves around. because it's based on how people are feeling, what's the demand, what's the competition, what's going on with the price of oil, what's going on. So it's always moving. So it's a moving target. So financial analysts are always, okay, today we want to do this and this. Okay, we want to change the price of this. Okay, we better react to this. Holy crap, I don't want to do that. But that's, oh, do you guys kind of see what I'm saying? So this is applicable in the real world. Now, what's really true is very often the function looks like this, and it's got a couple of peaks. And you're like, we could never get here, so let's settle for this. You know, so you can kind of work with it like that. I don't know if you guys kind of get me. So obviously, not only parabolas have a maximum and a minimum, anything that turns like that has maxes and mins. They could have several maxes and mins. And one thing we'll talk about today is how to find those in the calculator. I mean, if you remember when you go to intersect, there's also two things that says maximum and minimum. It's kind of a giveaway. Okay. Cool. So, tell me, would this have a max or a min? How does it open? Does it open up or down?
It would have a minimum.
Well, let's start here. Does it open up or down? Why up? Because it's positive 4. Right?
Means it has a minimum.
Which means it has a minimum. Exactly. How do I find that minimum? Well, the minimum is also called the vertex. How do I find the vertex? Good. All right. So vertex looks like this, of course. And the x piece is negative b over 2a. So let's go ahead and do it real quick. What's negative b? Negative 2. Good. Over twice a. Comes out to be 1/4. Ooh, I like it already. Sounds like something I would do. So then that's the x piece of the vertex. How do I get the y piece? Plug it in. Too many people give up right here. But come on. 1/4 squared. 1/16, right? So it'll be 4 over 16. Is that cool? 4 times 1/16 minus, 1/2 plus 1. So this is 1/4 minus 2/4 plus 4/4. Let's make everything 1/4, right? Please don't give up here. Or some people just give up here. Plug it in and just see what happens. Is everybody cool with this? I mean, this is not a big deal here, right? Plugging a 1/4 into this, doing what it said to do. And then I get, what, 4 minus 2 is 2, plus 1 is 3/4. So where's the vertex? 1/4? 3/4. So let me ask you this. What is the maximum, what's the minimum value of this parabola? What's the minimum value? 3/4. I love it. Where does the minimum value happen? 1/4. So very often x says where, and the what is the output. Yes?
We're finding the maximum, would that be different?
No, it's the same exact process. Because for a maximum, it would be a down parabola, and what's the name for the maximum? And then it's still the vertex. So the vertex is the location of the extreme, minimum or maximum, right? But it can only have one. Can a parabola have a max and a min?
No.
No, of course not. A cubic could. A cubic could turn twice. We talked a little bit about this yesterday. If it's a cube power, it can turn twice. If it's a fourth power, it can turn 3 times. So if I have a cubed, it could look like that. So it could have a max and a min. So if you're a prophet, you want to stay away from there, and maybe try to get closer to there. All right, maybe. So there are questions in the homework about max and min. You just interpret that to mean vertex. What makes this a max? Opens down. What makes it a min? Opens up. That's all. Yes?
For the vortex formula and the quad formula, are we doing those on the test tomorrow as well?
Yes. Sorry, I saw you. You visibly went, oh shit. Yes?
So for that, if it has x squared minus 3x, we would just make...
Oh, okay. So the function you're looking at is x squared minus 3x?
Uh-huh.
What's C?
0.
Good, I love it. All right. So does this have a min or a max?
Minimum.
Why?
Um,
Because it opens
yeah. No.
up, because it's positive. It's the x squared, it's positive.
Okay.
So it opens up. I like it. All right. So, in fact, in 176, you learn the highest degree term tells me what it does on the ends. Does it go up? Does it go down? Okay, maybe. Well, that's later. So right now, we just know the A is positive. So this opens up. So it's going to have a minimum. Where would that minimum be? Vertex. So now you interpret the question to be, find the vertex of this parabola. Right? And then the y value is what the min value is. And the x would be where the min value happens. So it depends on what they ask, yeah.
The negative b over 2a.
Beautiful. Negative b over 2a. Okay, yeah. So again, for this one, it would be negative b over 2a. And then you throw the 3/2 back in. Cool. Okay.
Did you use translation up, down, left, right?
So, x squared, where's its vertex? Oh shit. Where's the vertex for just a normal parabola? It hasn't been moved anywhere. 0, 0. Cool. That's the lowest it could be. The lowest you can get, when I say square a real number, the smallest number you can give me is 0. 0 squared is 0. Everything else is going to be some positive number bigger than 0. And then 1, 1, and negative 1, 1. So this is what the base, this is what I call the base function. Looks like the u. So if they say, use translations to do this, what kind of shift would that be? Now let me ask you this. Is that 3, is it in with the x, or could I put it with the y? Yeah, so the alternate thing, we'll talk about this first, and then here's the other thing, just to show you what I mean with in with the x, it would be like this. Now that's in with the x. Do you see that? So if it's in with the x, it's going to move left and right. Why? Because what's the x-axis do?
Left and right.
And if it's out here, that means I can put it with the y, and it's going to move up or down, because that's what the y-axis does.
Wait, how did that become X?
No. 2 separate problems.
Okay.
Okay, I like it. Thank you.
Okay.
So, no, be careful. What's this going to do? It's going to take all the old outputs and make them 3 more than they used to be. So I love this. Yes?
I was wondering, with these, you have the MX plus B, but you can use line number 1 at all for these.
There's no mx plus b here. You got to be real careful. I said it was sort of related to slope. But what's the big difference here? Why does m not mean shit here? Because the slope, is it always the same? No. So a line is the only one that can say slope is 7 or something. Because it's always 7. Here, if I said, what's the slope of this? It's everything, right? Because it's negative, and then it's 0, and then it's positive. So the slope is changing everywhere. So the minute I have something that's not a straight line, I can't talk about m anymore, right? But you do, I always feel like I'm going to scare you guys, but don't be scared. All that calculus does is we talk about, how do I find the slope of some curve at a point? So like here, there's a slope. There's a slope here, a single slope right there. But if I move a little bit, now it's bigger. If I move backward a little bit, now it's smaller. So calculus says, can you tell me a way to find the slope at any specific point? There's got to be a way to do that. I'm sorry. That's enough. Sorry. That's all. And the minute I say calculus, people, it just hurts people somewhere. I understand. Here's the thing. People really focus on this. This is going to move it which direction?
To the right.
No, there.
Yeah, left 3. This is going to move it up 3, and people go, what the shit? But, again, what did this take the place of? What used to be here before we talk about functions? What letter was there? Y. And couldn't I put the 3 with the Y? So see now, I really want, it's the same thing. If you put it with the letter, you do the opposite of what it says. Because you're thinking about what would make this 0. -3 would make it 0, so it's going to move back 3. What would make this 0? +3, so it's going to move up 3. But to me, this is even makes more sense. It's just, whatever x squared used to be, is now 3 bigger. So the whole thing just goes up 3. So if I wanted to graph G, I'll do G in black. It would go up 1, 2, 3, up 1, 2, 3, up 1, 2, 3. There's G. There's the G function. And how do I check it? If I put a 1 in, I'm supposed to get a 4 out, right? 1 squared is 1 plus 3 is 4. Check. Nah. So what would this do? Take every point and move it back 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So here is the H function. Took the parabola and moved it back 3. And how do I check it? Yeah, if I plug in -2, I'm supposed to get a 1 out, right? Just looking at where I ended up. When I plug a -2 in, -2 plus 3 is 1 squared is 1. So I do get a 1. So the point is correct. So lightning round. How would this move it?
Down 6.
Down 6. Is that cool? What would this, so that's number 1. Number 2. What would this do? Upset. What would this do? Left 5. I mean, you guys get the idea, right? I mean, that's... So you take the base parabola, 0, 0, 1, 1, -1, 1, and you just move it. Right? Yes?
Can you only do that with a base function?
Well, yes. You always want to start with, take the translation away. That's the base function, and then you move it by that much. So if I take the translation away, it's x squared, base function, and then moves by that much.
Okay, so if it's something other than x squared,
Beautiful, I love it. It could be square root of x. We looked at one yesterday real quick.
you just find that point and move it.
And exactly, so how much would, which direction would this go?
Can you do this with other formats, or does it have to be in the g of x, h of x?
Well, it's got to be a function. Well, it doesn't even have to be a function, to be honest. So you could do this. All right. Real quick, how would this go?
4, right?
Yeah, right 4. So square root looks like 0, 0, 1, 1. What's the square root of 4? 2. So that's the base function. This would take it and move it every point right 4. So now it would be over there. That's all it would do. Just move it right 4. What's the smallest number I can plug in there?
0.
No. To have a real, I'm talking about when I'm graphing stuff, we have to have it come out real.
4.
4. Anything below 4 is going to make it negative inside. Not real. I can't graph that shit. You guys don't want to get into graphing imaginary functions. No. Let's not go there. So the smallest real number I can use is 4. That's why it starts here. That's the smallest real number it can use is 4. Do you see that's why it has to start there now? Okay, maybe. But coming back to your question, this is getting a little ahead of us, but stay with me for a second. This is a circle of radius 3. You see how that's 3 squared? So it's like the Pythagorean theorem almost. So a circle would say whatever x is, whatever y is, I want to go some combination of those two things. So x squared plus y squared equals 9 would be, this radius is always 3. So the radius is always 3. So I get this nice circle. And it's centered at the origin, centered at 0, 0. So what would this do? That would take that circle and it would move it. You could do it right 2,
Back 1.
Up 1?
down 1. When it's with the letter, you do the opposite. What makes that 0? 2. So it's going to move right 2, down 1. I like it. So why is that one kind of like the opposite? Because it's not with the letter. If I put it with the letter, then it follows that rule. All right, I really want you guys to get that. When it's with the letter, it's the opposite of what I see. Do we have to know anything about circles yet? No, but I love this example because is that a function?
How is it without the letter?
How is this a function?
No.
No. What's up?
Because if it's with the letter, what if it's not?
Well, like I said, here it goes up 3. I can see it goes up 3. It takes the old parabola and it moves it up 3. But people focus too much on the fact that this would go back 3. And people are like, well, why does it go up 3 and this goes back 3? Because that's not with its letter. That is. So if I move the 3 over to be with its letter, I can see it's the same idea. You move the opposite direction of what I see. How would I move this? I'd still move it up 3. Do you guys see what I'm saying? Where's the 3 here? Is it with the x or no?
Yes.
Yes, it's with the x. If it's with the letter, you do the opposite of what you see. You try to make it 0 here. What makes it 0? -3. That's why I moved back 3. Is that with the letter? No. So if I moved it, and you don't have to, but if I did, it would be the exact same idea. What makes this 0? 3. So I'm going to move it up 3 because y is up and down. Okay, maybe. Yes?
So, same exact kind of situation, but it was 1 over 10 x squared.
Oh, all right.
And then it added.
So that's in my little list of things to finish talking about. No, you're perfect. You're like leading me into this. It's crazy. Let's start with something not so, well, that's not too bad, but let's start with something that's easier to see. So again, I graphed this enough times, you go a little insane. 0, 0, 1, 1, -1, 1. I can always do those anchor points, I call them. So that's my base function. Looks like that. So what would happen if I did this? Here's my old function, right? There's my old function. So g of x is going to take all the old outputs and
Multiply by 2.
double them. I love it. So now, this used to have an output of 1 for 1. Now where's it going to have an output? 2. That's crazy. What about this one? Used to be 0. Now it's going to be 0. And this is going to be there. Bam. Is that one skinnier or fatter? Skinnier. So this is, again, you should see how this is related to slope. Which one would you say is rising faster? The purple or the black line? Purple. And it sort of has a bigger slope. It's not really the slope, but it's related to the slope. Right? Sort of like if it's negative, it goes down. If it's positive, it goes up. If it's bigger than 1, it gets skinny because it goes up faster. So what if I used 1/2 x squared? Now this used to go to 1, but now it's going to go to 1/2. This used to go to 1, now it's going to go to 1/2. Now it's gotten what? It's gotten fatter. Or wider. I think the book uses wider. I can't remember what word they used. So number bigger than 1 is going to make it skinny. Why does that make sense? Because it's going to rise quicker. A number smaller one's going to make it fat, because now it's going to be like, all right, I'll get there. Okay, maybe. In fact, like dishes, you have parabolic dishes, like for dish TV or something, or, the big dishes that they use to try to contact aliens, or get signals. You kind of with me? And you can talk about the equation of their surface. And very often they have a number smaller than 1 in front because they are fat, so they can catch a lot of information, right? They have parabolic spotlight kind of stuff, lenses and stuff. Anyway, so these equations can be modeled to construct something to do a specific job, right? So you can change how wide it is by changing the equation, and that could inform how the people are going to construct it. That's how math works. Oh, yeah. Part of it. All right. Maybe.
You know how you did the 2x squared, so we're only changing the value of y. We're only times the value of y from the original function.
Exactly, because I can see it right there. There's the old ones, and then I double them. There's the old ones. I cut them in half. I like it. And of course, my teacher training, let me draw this one in blue, but I'll put it in purple. So I want to make sure that's in blue up there, right? This one, and this one's in purple up there on the graph. And again, so big number in front, bigger than 1 makes it skinny because it's going to rise faster. Smaller than 1 makes it fat. So there's a few questions there about will this be wider or narrow? I think they use narrower than x squared. But that's all you look for. So would this be wider or narrower? Wider. I like it because it's like pushing it down. But you're only going to rise 1/10 as fast. Oh man! So it's going to be really wide, right? Because now instead of going to 1, that bad boy would go to 1/10. Holy shit! Does that make sense? All right. I don't think they do too much asking you to. I think mostly that's related to wider and narrower. Yeah. Okay. So let me see, what have I not done yet? We talked about wider and narrower, max and min. And again, when you see max or min, you think vertex, because that's the only place it could happen. We talked about the discriminant, so there's only one thing left that I didn't talk about yet.
Wait, that's how you don't solve that one?
How do you mean solve it? Do you mean graph it?
Yeah, because then it adds as a function of tide after you do the initial one. But somehow,
How do you mean, sorry?
that's this. So I get how the equation is 0, x is equal to, I get all that, so it changes it to -5.
Oh, it's just